Welcome to this video. Today we are going to see about vector spaces and some theorems on the vector space. So first we define a vector space. A vector space V over a field F. It consists of a set on which you have two operations. One we call it as vector addition, where we consider two vectors x and y in V. Then when we add x plus y, that will be a unique element and also an element of V. Then the second one is scalar multiplication, where we consider a scalar in F and a vector from V. Then Ax belongs to the vector space V, and these two together will satisfy these 8 conditions. The first one we call it as commutative under addition for any two vectors x and y in V. X plus y, if you take, it will be equal to y plus x. The next one is associative under addition, where three vectors are considered x, y, z in V. X plus y we add and then z, that is same as x plus y plus z. Then existence of identity 0, x plus 0 will be equal to x, and inverse any x in V will have minus x belonging to V, such that when we do that vector addition x plus minus x, the answer will be 0. And for all x in V, 1x if you take, the answer will be x. And AB, when I multiply with x, it is same as a into bx, where these a and b are from the scalar field f. A into x plus y is same as ax plus ay, and the last one is a plus b into x, ax plus bx. This is like our distributive property. So any linear space which satisfies these 8 conditions, then we call it as a vector space. Now we are going to see theorems in vector spaces, and few we call them as properties too. So the first one is cancellation law for vector addition. Whenever we take three vectors x, y and z in V, such that you have x plus z equal to y plus z, then it is possible to cancel that common vector z on both sides to get x equal to y. So how we are going to prove this? Let us consider V to be the additive inverse of Z. What does it mean by additive inverse? Whenever we add Z and V, the answer should be 0. Okay, so now let us take x. X can always be written as x plus 0. Now replace the 0 by Z plus V from the previous line. Now use associative property. Instead of associating Z and V, let me associate x plus Z. So I can write it as x plus z plus b. But x plus z is same as y plus z from the given equation. So I am replacing it again associative property y plus z plus v. But z plus v, we have taken it as 0 because v is the additive inverse of z. So I am able to get that z plus v as 0 to give me y plus 0. But y plus 0 is y, therefore x is equal to y. So this is what we call it as the cancellation law for vector addition. Then the next theorem, the additive identity element of V is unique. Every element can have only one additive identity. Suppose there are two, E and F, they are going to be the identity element of X. What is the meaning of identity element? You add it with X, you will get back X only. That is the meaning. That is what is equation 1 and 2. But from 1 and 2, we can take X plus E is same as X plus F. Now by cancellation law, we can cancel that X on both sides to give E equal to F. So what did we consider? We considered two identity element, and we are able to prove that they are the same, meaning is the additive element is unique. So we go on to the next property. The additive inverse element is also unique, meaning is for one element x, there can be only one additive inverse. So again, we will consider two elements y, y dash to be additive inverse of x. So by the definition of additive inverse, whenever you add the element with its additive inverse, the answer should be 0. So x plus y, same as y plus x, the answer should be 0. x plus y dash plus x will also give me 0 because y dash are both additive inverses of x. Now from these two equations we get x plus y is same as x plus y dash. Again using the cancellation law, cancel x on both sides to give y equal to y dash. Thereby we get the additive inverse for any element. If you take, it can be only one element, not more. Okay. So now the next theorem. In a vector space V, we are going to prove these three. First one is 0x equal to 0. This 0, whatever we have in this, is from the scalar. It is scalar 0. Okay, so scalar 0 multiplied by x is going to give me 0. That's what we are going to prove. So this scalar 0 can be written as 0 plus 0. Okay, and then also I can write the 0x as 0x plus 0x. It is possible to write it that way also. So now from 1 and 2 I am able to get 0x plus 0 is equal to 0x plus 0x. Now again use cancellation law, cancel 0x on both sides to give you 0x equal to 0, which is our first claim. Now we go on to the second one. In the second one, we need to prove minus a multiplied by x is equal to minus of ax, or a into minus x for all a in the scalar field and x is a vector. So now for all a in a, we know that whenever there is a scalar, you can have the negative of that. Minus a is also possible and 0 is also there in f. And just now we have proved that 0x equal to 0. Now this scalar 0, I am writing it as a plus minus a. Okay. Now apply distributive property with this a plus minus a into x. So it is ax plus minus a into x equal to 0. Whenever we add two elements and the answer is 0 vector, then we'll call one vector as the inverse of the other. So minus a into x is known as the inverse of ax. So what is the meaning? Minus a into x is equal to minus of ax, inverse of ax. Same pattern, you will be able to get a into minus x also as minus of ax. Therefore, we can conclude that minus a into x is equal to minus of ax equal to a into minus x. Now, the third one, a into 0 equal to 0. Here we are talking about the vector 0. 0 is from the vector space. So now I can write this vector 0 as 0 plus 0. Now distributive property, a into 0 plus a into 0. Now from also we know that what is a0? A0, any vector can be written as that vector plus 0. Okay, so now combine 1 and 2 and use cancellation law to get a0 cancelled on both sides to give a0 equal to 0.